Hi girls, this is Miss Paige here. Happy Monday. I hope everybody had a great weekend. Before we get started, I just want to review a couple of things. One thing that I would like to review is our vocabulary of equivalent fractions, okay? So equivalent means equal, okay? And let's remind ourselves as to what equivalent means. Equivalent fractions are when two fractions are equivalent if they are the same size or at the same point on a number line. Okay, so that is what equivalent fractions means. Let's have a review up here of our lesson from Friday. Okay, so I have two examples up here. I have this red and this red shape here. They're both just one whole and they're equal size. Okay, one half is shaded here, one half, one part is shaded out of the two equal parts. Over here we have 2/4. Four equal parts, two of them are shaded. And we can say that one half is equivalent to 2/4 because, and remember, Miss Simon went over this, 1 times 2, if we double it, that means if we multiply by 2, you get 2, which is the same as this fraction. 2 times 2 is 4. If you double 2, you get 4. Okay, and that is equivalent to 2/4. I also put a number line up here for us to see. The top is split into halves. Okay, the one whole from here to here is one whole. It's split into halves on the top, 0 halves, 1 half, 2 halves, which is the same as one whole, which is what we have represented here. The bottom part is split into fourths. 0/4, 1/4, 2/4, 3/4, 4/4. 4/4 is the same as one whole. 0/4 is the same as 0. These are equivalent fractions because they're both equivalent into the whole, but we can also see that 1 half is equivalent to 2/4. All right, let's have a look at the green down the bottom. Okay, this is 2/3. This is again still working within one whole. This is 2/3. 2 parts of shaded out of the 3 equal parts. That gives us 2/3. This is 4/6. 4 parts are shaded. 1, 2, 3, 4 out of the 6 equal parts. 1, 2, 3, 4, 5, 6. Okay? If you double 2 or you multiply 2 by 2, you get 4, 2, 4. All right, 2, 4. If you double 3 or multiply 3 times 2, you get 6. 3, 6. All right? And that'll give you 4, 6. The same thing on the top is this shape here. It's split into thirds. 0/3 is 0, 1/3, 2/3, 3/3, which is the same as one whole. On the bottom is split into 6. 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. This is 1 also. These are equivalent fractions. They're at the same spot on the number line. 0/3 and 0/3 and 0/6 are also equivalent fractions. They're at the same spot on the number line. We can see that 2/3 is equivalent to 4/6 because they're at the same spot on the number line. Okay. Additionally, 1/3 and 2/6 are equivalent fractions because they're also at the same spot on the number line. All right. What's important to recognize is in this lesson here, there's only one whole. Okay. You're going from 0 to 1. All right. In the lesson that we're going to do today, we're going beyond just one whole. All right. So our ICAM statement for today for Module 5, Lesson 23, called Same Spot. The lesson is called Same Spot. And it's I can generate simple equivalent fractions by using visual fraction models and the number line. All right, that's what I'm going to put up on the board, and we're going to go through 2 different examples all together. All right, so let me take our review off here. And let's have a look up here. All right. So if I draw our number line, okay, and the number line here starts at 2, and it has 3, and it has 4. All right, I'm just going to take this part out. 2, 3, 4. Now it's not starting at 0 and ending at 1, but from here to here is one whole, and from 3 to 4, this is also one whole. All right, so if we split it up first into halves, that means from here to here, there needs to be 2 equal spots, 2 equal. All right, so I'm going to do this halves in green. Here, okay, 2 equal parts in the whole. Same thing, one whole, if it's split into halves, it needs to be into 2 equal parts. All right, not the whole number line, between the one whole. All right, 2 to 3 is one whole, 3 up to 4 is another one whole. All right, they're split into halves, 2 equal parts, 1, 2, 2 equal parts from here, 1, 2, 2 equal parts from here. Okay, now if I split it into fourths, it would be into 4 equal parts. All right, between the whole needs to be split into 4 equal parts. So I can do 1, 2, 3 lines gives me 4 equal parts. 1, 2, 3, 4. All right, 1, 2, 3, 4. Now, because to get to get to halves up to fourths, I need to double 2. 2 times 2 is 4. So what I can do is I can split the part that I have up already. I can keep that spot on there, and that'll give me 2 parts in there. All right, now let's have a look at how we can label this. Now, 2 in halves, that's a little difficult for me to just think of what that would represent or what that would equal. So the easiest way to do this is take 2 wholes, okay, because that's what that represents, 2 wholes, and split them into halves. All right, split it into halves here, split it into halves. Now, how many parts do I have? I have 1, 2, 3, 4 parts that are being counted for. 4 parts that are being counted for. 2 equal parts in the one whole. So the denominator is always 2. Okay, so this is 4 halves. 1, 2, 3, 4. And we know we just counted up. 4 halves, 5 halves, 6 halves, 7 halves, 8 halves. All right, so now I have my halves labeled. Let's have a look for my fourths, how I can label my fourths. Same thing. What is 2 wholes equivalent into fourths? I get my 2 wholes and I split them into fourths. Okay, so 2 in fourths is equivalent to 1, 2, 3, 4, 5, 6, 7, 8. It's equivalent to 8 fourths. All right, and again, you count up 9 fourths, 10 fourths, 11 fourths, 12 fourths, 13 fourths, 15 fourths. Oh, sorry, I forgot about 14 fourths. That's not 13 fourths, 14 fourths, 15 fourths, and 16 fourths is equivalent to 4 as a whole. So let's have a look at all our equivalent fractions on this number line. I can say that 4 halves is equivalent to 8 fourths. I can also say 5 halves is equivalent to 10 fourths. I can say that 6 halves is equivalent to 12 fourths. And I can say that 7 halves is equivalent to 14 fourths. And I can say that 8 halves is equivalent to 16 fourths. Okay? Now I'm noticing a pattern. Do you notice the pattern? I notice that if I double my numbers, that means I multiply them by 2, I get the other fraction. 4 times 2. Well, that doesn't work. 4 times 2 is 8. So that matches up. 2 times 2 is 4. Okay? Same thing all the way around. 5 times 2 is 10. 2 times 2 is 4. 6 times 2 is 12. 2 times 2 is 4. 7 times 2 is 14. 2 times 2 is 4. 8 times 2 is 16. And 2 times 2 is 4. So if you double the fractions, top and bottom, numerator and denominator, you will get equivalent fractions. All right, let's have a look at another example up on here. Okay. If I have thirds, that means the whole needs to be split into 3. All right, so if I have my number line, and I start this time at 4, 5, and 6. Now, the arrows show me that there's whole numbers that come before 4. We know that 0, 1, and 2, and 3 come before 4. But this arrow also tells me that there's whole numbers that come after 6. So 7, 8, 9, all the way along. All right? So let's have a look. If I split up the whole into thirds, that means I need to add 2 lines on here to get it into thirds. 1, 2, 3. Now, remind you, you're not splitting the whole number line up. You're splitting up the wholes, just one whole. Okay? Now, same thing. I want to remind us how we can figure out what 4. Well, how do I get 4 as a whole number into thirds? I need to take 4 whole. Okay, they're all the same size. I need to split them into thirds to see how many parts are being counted for. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So I have 12 thirds in 4 holes. Okay? And again, I just count up. 12, 13 thirds, 14 thirds, 15 thirds, 16 thirds, 17 thirds, 18 thirds. Okay? And now if I want to split it also up into 6, that's 6 equal parts in the whole. Now again, I can split it up. 1, 2, 3, 4, 5. 5 lines gives me 6 equal parts. Same thing over here. 1, 2, 3, 4, 5. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Okay, now I have them in there. However, I'm working with 4 holes. All right, so let's see. 4 holes. Split up into 6 to see how many parts I have in 4 holes. Okay, let's count up all the parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, in four holes, I have 24 sixths. Okay, 24 sixths, 25 sixths, 27 sixths. Oh, I always skip the number we're counting by. 25 sixths, 26 sixths, 27 sixths, 28/6, 29/6, and 36. 31/6, 32/6, 33/6, 34/6, 35/6, and 36/6. Okay? Let's have a look and pull out our equivalent fractions to see what we notice. So I notice that 12/3 is equal to 24/6. All right? And I notice that 13/3 is equivalent to 26/6. All right? 14/3 is equivalent to 28/6. 15/3 is equivalent to 36. 16/3 is equivalent to 32/6. 17/3 is equivalent to 34/6. And last but not least, 18/3 is equivalent to 36/6. All right, same thing. If we double up these numbers, now I don't expect us to be able to double up 17 real quick, but if we did 17 times 2, or 17 add 17 add 17, then you would get 34. The same thing, if you times all these numbers by 2, 12 times 2 is 24. If we double them up, 3 times 2 is 6. 14 times 2 is 28. 3 times 2 is 6. If we double up all these fractions, then we will get our equivalent fractions. If we double up these numbers, we will get our equivalent fractions. All right, that is us for today's lesson. Thank you for listening on in. Go ahead and go on to Zern lesson 23. Complete all components. I can't wait to see your good work. Have a good day.